All right, welcome back. This is Mr. Humbard here. Let's go through this assignment. For this assignment, I'm going to use the fact that G is 9.81. So 9.81 meters over second squared. And let's get started. So our first question is over kinetic energy. So kinetic energy is 1/2 mv squared, which is 1/2 13.5 times 8.1 squared. That's going to be our value. To get that answer, we can do 0.5 times 13.5 times 8.1, then squared, or times 8.1 again. And I'm going to get I made a mistake here. That's in grams. This has to be in kilograms for this to work. So this, and the reason I noticed that is I saw that my answer was off. I had 2.86. So it happens to me too. 7.5, but I'll skip that. It's fine. I need to change this 13.5. That's in grams. So we know that 1,000 grams equals 1 kilogram. So that means that if I want 13.5 grams, I want to convert that to kilograms. So 1 kilogram over 1,000 grams. So divide that number by 1,000, and I'll get 0.4428. And I will actually just, this is 2 decimal places. Here's my third decimal, it's a 2, so I leave that off. So 0.44 is my answer. Joules. We don't put the joules though, because of grading purposes. So here's number 2. Number 2 is this kinetic energy of a small boat being this value, 45,850. And here's our speed. We want the mass of this boat. So if we solve that out, 45,850 equals 1/2 mass times 2.9, and has to be squared because 1/2 mv squared is kinetic energy. And I'm going to find what mass is. Its mass is going to be 45,850 divided by whatever 2.9 squared times 0.5 is. And that's going to be 10,903.68609, but I won't put that. I think it just wants no decimals, so there's a 6 here, so we round that up to 4, and we get 10,904, sure enough. That's going to be our mass in kilograms. So here we have this cliff diver. He drops this water from height, and his potential energy is 26,573 joules. We want his mass in kilograms. The answer is in 1 decimal. So MGH equals potential energy. If I plug all these values in, I'll get 26,573. That equals 58, which is height, times the acceleration due to gravity, 9.81, times his mass, which we'll put here, m. So m equals whatever that value is, 26,573. Divide all that by 5.8. No, 58. My bad. Times 9.81. By 58 times 9.81. Notice I put the parentheses on the bottom, so nothing got not divided. So 46, if it's to one decimal, 0.702, but it's to one decimal, so we ignore that. We cancel that. So 46.7. And that's going to be kilograms. Right. So here's our, this is a gravitational potential energy problem, so mass times gravity times the height. So 6.1 times 9.81 times 1.1 equals our potential energy, which is 6.1 times 9.81 times 1.1 will give us 65.8251. And I can round that up to 66, and I'll get my answer in joules, which we don't write for grading purposes. So 55. It's another speed problem with kinetic energy. Kinetic energy equals 1/2 mv squared. So plug in my values, 15.26 equals 1/2 0.27 velocity squared, which we don't know. I can solve this for that, and it's going to be square root 15.26 2 over 0.27. Just a little bit of math. Or you could simplify this. It would do the same thing and just divide it over. So that answer, V, is going to be square root 15.26 times 2 divided by 0.27. I should get 10.63, 2 decimals, 1, but it's 2 decimals, so like the 10.63188. We'll just ignore all that because there's a 1 there. So 10.63. All right, final problem. For this one, oh, there's one more. Final couple of problems. Here's our potential energy, 9.2. We're going to use MGH equals potential energy. So 9.2 equals 0.3 times 9.81 times the height, which we don't know. So height is going to be 9.2 divided by 0.3 times 9.81. So open parentheses, 0.3 times 9.81, close parentheses, 3.126, and if it's 2 decimals, it's 1213, 3.13. Meters. All right, for this problem, all we do, this is the spring constant K. Here's our X value, distance. All we do is just follow this equation. 1/2 K 96 times X squared, 2.9 squared. So 0.5 times 96 times 2.9 squared. 403.680, which they add right there. All right, and that's it.